Welcome to grade 9 CBSE mathematics class. I am Sudhi here. Today we are going to discuss about chapter number 15, probability. So what is mean by a probability? Probability is simply chances. What type of chances? So the thing is that, for an example, today all like cricket match. The thing is that before each and every cricket match, there is a toss should happen. What happened in the toss? Each captains have a possibility to win and lose the toss. There is a 50% chance to win and lose the toss by each captains. That simply means that if Virat Kohli, the previous Indian captain, went for toss, and there is a chance that Virat Kohli won the toss and lost the toss. So this is simply chances. Chances is simply called a probability. So if a coin is tossed up, there is a chance that coin gives the result as tail or head. That chance is simply called probability. The simple thing is that if a coin is tossed, chances of head is 1. No, chances of head and chances of tail. There will be chances of head and chances of tail. This chance is simply called probability. And if a die is thrown, there will be 6 numbers are there in die from 1 to 6. That means chances of 1, chance of 1 is there, chances of 2 is there, 3 is there, 4 is there, 5 is there, and finally 6 is there. This chances is simply called probability. So there is a chance an event should happen or should not happen. So that chances is simply called probability. So we have to check another example such that another example is if Cristiano Ronaldo took part in shootout. Which shootout? Penalty shootout. So with respect to a match played by Cristiano Ronaldo, there is a chance Cristiano Ronaldo will score the goal and will not score the goal. So there is a chance such that will score the goal or will not score the, we doesn't know what happens next. So there is a chance, there is a probability such that he scores the goal or he may not score the goal. So that is simply called probability. So the next thing is that how to find the probability of an event. Before moving that, how to find the probability of an event such that we have to identify two terms such that sure event and impossible event. What is mean by a sure event and what is mean by an impossible event? So here today is Sunday. Then one person say that tomorrow is Monday. Today is Sunday and tomorrow is Monday. So as we all know that if today is Sunday, then tomorrow is Monday. So this is a sure event. So tomorrow is Monday. This is a sure event. So there is 100% chance that tomorrow is Monday. So this event is called sure event, such that the probability is 100%. That 100% in probability means that 1. 100% in probability means that 1. So 100% there is Monday tomorrow. There will be no chance related to tomorrow is Tuesday or tomorrow is Wednesday or tomorrow is Thursday or tomorrow is Friday or tomorrow is Saturday. Tomorrow is simply Monday. Today is Sunday, tomorrow is Monday. That is simply called sure event. Saying today is Sunday. Somebody says that tomorrow is Wednesday. Tomorrow is Wednesday. Is this happen? Is there any chance of Wednesday tomorrow? No, because this event is called impossible event. Impossible event. The chances of this should be happen is 0%. That means in probability we have to say that it is 0. So for a sure event, the chances in percentage is 100% and its probability is 1. For an impossible event, it is clearly mentioned that for an impossible event, the chances are 0% and in probability it is mentioned as 0. So if there will be chances in between them for any other probability, for a chances it lies between 1 and 0, or otherwise we can say that 0 and 1. Between 0 and 1, if there will be some chances are there in an event, if there will be some chances in an event, that chances lies between 0 and 1. That chances lies between 0 and 1. So the next step is, how will you find the probability of an outcome or the probability of an event? Probability of an event. So the first, for an example, if a coin is tossed up, so number of heads, we want to find out number of heads, probability of number of heads. For an example, we want to find out the probability of number of heads occur. So the thing is that the probability of number of heads and number of tail. So here, if a coin is tossed up, the number of heads should happen is should happen is 1. That means the thing is that if a coin is tossed up, there means number of heads. The chances of number of heads is 1 and the chances of number of tail is also 1. Simply means that there is a chance head should happen and tail should happen. So number of head is 1 and number of tail is also 1. So what happens to the probability? Probability of number of heads is equal to, the chance of head is 1 by total outcome is 1 plus 1 is 2. That is 1 by 2. 1 by 2 is 0.5. What is probability of number of tails? Probability of number of tails is equal to, again 1 by 2. How will you get 1 by 2? The chances of number of tails should appear is 1 and the total outcome is 1 plus 1 is 2. That is 1 by 2. That is 0.5. How will you analyze that these chances are correct? How will you analyze that the answer of this question is right? So the thing is that probability of number of heads plus probability of number of tails equal 1, then it is correct. So is it correct or not? Probability of number of heads is 0.5 plus probability of number of tail is 0.5. That is 0.5 plus 0.5 is 1. That means the answer is correct. So move to another example. Move to another example. Move to another example such that a die is thrown up. A die is thrown up. So a die is thrown up. First question, probability of 1 should appear. Second one, probability of 3 should appear. Third one, probability of 5 should appear. Okay, so this is the question. A die is thrown up. We want to find out the probability of 1 should appear, the probability of 3 should appear, and the probability of 5 should appear. The thing is that when a die is thrown, what are the total chances? The total chances is 6, such that how will you say that it is 6? In the case of a die, there is a chance of 1, there is a chance of 2. For every throwing there is a chance of 1 should appear, there is a chance of 2 should appear, there is a chance of 3 should appear, there is a chance of 4 should appear, there is a chance of 5 should appear, and there is a chance of 6 should appear. So these are the chances, total outcomes, that when a die is thrown. So what is the total outcome here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The total outcome, the total outcome is 6. So what is the probability of 1 should appear? Probability of 1 should appear equal 1 by 6. Probability of 2 should appear. What is the probability of 2 should appear? So how many times 2? There is a chance of 2 when a die is thrown. How many times? It's only one time. That is the probability is 1 by 6. What is the probability of 3 should appear? Probability of 3 should appear is equal to again 1 by 6. What is the probability of 4 should appear? Probability of 4 should appear is also 1 by 6, because there is only one chance that the dice will give the result of 4. Then what is the probability of 5 should appear? Probability of 5 should appear is probability of 5 should appear equal again 1 by 6. What is the probability of 6 should appear? That is again 1 by 6. So all the chances are 1 by 6. That means what about the total? Total chance is equal to 1 by 6 plus 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 1 by 6. 1, 2, 3, 4, 5, 6. That is 6 by 6, that is equal to 1, that is 100%. So the answer is 1. That means that this answer is correct. So this is the way to find out the probability of an event. This way we can find the probability of each and every event in the question. Now we want to discuss about more questions regarding probability. Right now there will be two questions on the board, such that the first question is, a coin is tossed 1,000 times with the following frequencies, such that the head should appear is 455 and the tail should appear is 545 times. Compute the probability for each event. That is the first question. So we can solve that first question. After the first question, we will move to the second question. This is the first question. So a coin is tossed 1,000 times. So the total frequency is, what about the total frequency or the total outcome? Total frequency is frequency equal 1,000 times. So the head should appear how many times? 455 times, and tail should appear 545 times. Okay. Number of heads equal 445. Probability of head should appear, probability of head should appear equal, how many times head should appear? 455 times, by what is the total probability? That means that is the total frequency, that is 1,000. So 455 by 1,000. The answer is 0.455. So number of tails, what should be number of tails? Number of tails equal 545. Probability of tail should appear. This will be taken as probability of head should appear is P of H, and probability of tail should appear is taken as P of T. You can use any other letter such as P of A or B or C or D or E, like that. So P of T, that is number of tails, is 545. Probability of a tail should appear is P of T. Then P of T, how can we calculate P of T? Number of tail should appear is 545 by total number of trial is 1,000. That is equal to 0.545. So this is the probability of getting head, 0.455, and this is the probability of getting a tail, 0.545. Is this answer right or wrong? Just add these two probabilities. If we got the value 1, then the answer is right. So 0.545 plus 0.455 is equal to 1. So the answer is right. So in some question papers, one more thing is there. In some question papers, it should be given that a coin is tossed 1,000 times with the following frequency, such that head equal 600 times. Compute the probability for head and tail. How will you find out this question? A coin is tossed 1,000 times with the following frequency such that h equal 600 times. That means when the coin is tossed 1,000 times, there will be 600 times head should appear. So we want to find out the probability for head and tail, which means that total outcome equal, that means total trial equal 1000. Number of times head should appear is equal to 600. That means number of times tail should appear is, how will you find out? That is total minus number of times the head should appear. That means tail equal 400. Now we want to find out the probability of head equal 600 by 1000. That is 0.6. The probability of number of tail should appear is 400 by 1000. That is 0.4. That means 0.6 plus 0.4 equal 1. That means this is correct. Moving to the second problem. The record of a weather station shows that out of the past 250 consecutive days, its weather forecast were correct 175 times. That means in a weather station, there will be 250 days data is there. There is a data for weather forecast for 250 days. So that from out of that 250 days, the weather forecast were correct 175 times. So that weather forecast were correct in 175 times out of 250 days. That means the other 75 days, that means 250 minus 175 is 75. The other 75 times it should wrong. So what is the probability of that on a given day it was correct? So total equal 250. Out of 250, correct will be 175. The probability of getting the correct one is taken as P of C, that is 175 divided by 250. That equal 35 divided by 50. That equal 7 by 10. That equal 0.7. Then what about wrong one? Out of 250, 175 is correct. Then the remaining 75s are wrong. So the probability of getting wrong is 75 by 250. That equal 0.3. 75 by 250 equal 0.3. 7 by 10, 175 by 250 is 35 by 50. That equal 5, 7 into 5, 35, 10 into 5, 50. 7 by 10 is 0.7. That equal 75 by 250 is 0.3. That equal, the total answer is 0.7 plus 0.3 equal 1. That means which is correct. So these are the answers of two questions of the above problems. These are the two problems. I think it will be clear to you. It was clear to you, such that these are the two questions. Okay. So there is another problem such that here is the problem. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. So the table shows the data of a distance covered versus what time the tire needed to be replaced. So this is the data. So there will be a frequency, the distance covered in kilometers and the frequency is given. And the question is, a tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. So if the vehicle covers less than 40,000, less than 4,000, there is 20 times there is a chance of tire to be replaced. Between 4,000 and 9,000, there will be 210 times there should be a chance such that the tire is to be replaced. Between the kilometers 9,001 to 14,000, there is a chance of 325 times the tire to be replaced. And greater than 14,000 kilometers, the vehicles, if the vehicles, not a vehicle, if the vehicles covers greater than 14,000 kilometers, there will be a chance of 445 times the tire to be replaced. So these are the frequency. So less than 4,000, 20, 4,000 to 9,000 210, 9,001 to 14,000 325, greater than 14,000 445. So what is the total number of trials here? The total number of trials is 20 plus 210 plus 325 plus 445. 445 plus 325, 325 plus 210, 980, 980 plus 20, 1,000. 1,000 times, the total trial is 1,000 times. Total trial is 1,000. So first question, what is the probability that the tire to be replaced before 4,000 kilometers? So before 4,000 kilometers, what is the probability that the tire need to be replaced? So probability less than 4,000 equal, what is the probability that the tire need to be replaced before 4,000 kilometers? That means before 4,000 kilometers, the probability is 20 by 1,000. 2 by 100, that is 1 by 50. 1 by 50. So the next one, what is the probability that the tire need to be replaced more than 9,000 kilometers? What is more than 9,000 kilometers means this and this. This is 9,000 to 14,000. This is greater than 14,000. Greater than 14,000 means greater than 9,000 also. So 325 plus 445. So P lies between more than 9,000, that is greater than 9,000, equal 325 plus 445 by 1,000. 445 plus 300, 745 plus 25. 745 plus 20, 765 plus 770 by 1,000. By 1,000. Cancel, that is 77 by 100. That is equal to 0.77. This is the probability. This is 1 by 50. This is 0.77. Next one. What is the probability that the tire need to be replaced between 4,000 and 14,000? So this is question number 1 answer, question number 2 answer, question number 3 between 4,000 and 14,000. So the range lies between 4,000 to 14,000 equal between 4,000 and 14,000. This is less than 4,000. 4,000 to 9,000 is 210. 210 plus 325. This is between 4,000 and 14,000. This is greater than 14,000 and this is less than 4,000. These two columns are not included. These are included. 210 plus 325. So the chances are 210 plus 325 divided by 1,000. 325 plus 200 is 525 plus 10 is 535 by 1,000. That equal 0.535. 0.535. So P of 4,000, total number of trial is 1,000. This is 325 plus 200, 525. 525 plus 10 is 535. 535 plus 535. So the total number of trial is 1,000. So 535 by 1,000 is 0.535. This is greater than 9,000. Greater than 9,000 means this 2. 325 plus 445. That is 325 plus 445 is 325 plus 445 is 445 plus 300, 745 plus 25, 770 divided by 1,000, 770 divided by 1,000 is 0.77. 0.77, this is 0.535 and this is 1 by 50. These are the chances. These are the answers. So moving to the next question. So moving to the next question. The given table shows the percentage of marks obtained by a 10th grade student in his unit test. Test percentage of mark. Test 1, test 2, test 3, test 4, test 5. In test 1, he obtained 70 percentage mark, test 2 60 percentage mark, test 3 80 percentage mark, test 4 90 percentage mark, test 5 50 percentage mark. So these are the marks in percentage obtained by a 10th class student in his unit test. There will be, from this table we can find out lot of probabilities that we make some questions and answers so that this portion will be clear to all of you. Such that the first question is, find the probability of getting more than 60 percentage marks in exam. So find the probability of getting more than 60 percentage mark in exam. So how many unit tests are there? There will be 1, 2, 3, 4, 5. 5 unit tests are there. Total trial equal 5. Now find the probability of getting greater than 60 percentage equal how many times he score more than 60 percentage mark. This is not be included because this is 60 percentage. We want to find out getting more than 60 percentage. This not be included. More than 60 percentage here. 70 percentage is more than 60 percentage. 1. 80 percentage is more than 60 percentage. 2. 90 percentage is more than 60 percentage. 3. So there will be 3 times he score more than 60 percentage. 3 by, what is the total number of trials? 3 by 5. So the answer is 3 by 5. What about 3 divided by 5? 0.6. 3 divided by 5 is 0.6. So the probability is equal to 0.6. What is the probability of getting less than 80 percentage? Probability of getting less than 80 percentage mark. Less than 80 percentage mark. That equal less than 80 percentage means this should not be included. Less than 80 percentage. That means this should not be included. This is 80 percentage. So less than 80 percentage mark means one time he got marks 50 percentage. So this is 1. 60 percentage is less than 80 percentage. 2. 70 percentage is less than 80 percentage. That is 3. So that's also 3 by 5. That equal 0.6. So probability of getting less than 80 percentage mark is 0.6. Probability of getting greater than 60 percentage mark is 0.6. Probability of getting exactly 90 percentage mark. Probability of getting exactly 90 percentage mark. Probability of getting exactly 90 percentage. That means probability equal to 90 percentage. So how many times he got 90 percentage mark? It's not more than or not less than. Exactly 90 percentage of mark. Probability of getting exactly 90 percentage of mark only one time. And the fourth unit test he got 90 percentage mark exactly. That means one time he got 90% mark, that is 1 by 5 equal 0.2. So probability of getting the marks between 60 to 90. Probability of getting the mark in between 60 to 90. 60 to 90 means we have to take 61% to 89.99, 60.01 to 80. This 60 and 90 not be included. Between 60 and 90, how many times you got the marks? How many times? 60 to 90 means 70 lies between 60 and 90, 80 lies between 60 and 90. 60 and 90 not included because between 16 and 90, not including 60 and 90. That is 2 times he got the marks between 60 and 90, that is 70 and 80. That is 2 by 5, that equal 0.4. 0. So what is the probability of getting less than 50%? Less than 50% mark. What is the probability of getting less than 50% mark? Less than 50%. First unit test he scores 70%, second one 60%, third one 80%, fourth one 90%, fifth one 50%. There will be no unit test he score less than 50% mark. So the probability of getting is 0. So probability of getting greater than 90% mark. So in any unit test he score greater than 90% mark. He score 90% mark, but not more than 90%. So probability of getting greater than 90% is also 0. So with respect to this condition, we answers all the questions. So these are the in question papers for board exam there will be some tables are given. In the annual exam some tables are given and the questions are already given. We want to answer that type of questions. From the tables we have to find out the answers. You have to keep looking into the table such that to analyze the condition given in the question. So with respect to that condition, we have to apply the table with respect to that condition and find out the probability of the given question. That is the way of finding questions from answers from tables. So this is the answers to the question. So next 2 questions. Here the first question is, in a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. Find the probability that she did not hit a boundary. So the first question is, what is the first question? In a cricket match, a batswoman hits a boundary 6 times out of 30 deliveries, 30 balls. That means out of 30 deliveries he played or she played, she hits boundary every 6 balls. Boundary 6 times out of, not every 6 balls, she hits boundary 6 times out of 30 balls. 6 times out of 30 balls. Now not every 6 balls she hits boundary 6 times out of 30 balls. Out of the 30 delivery she played, she hit 6 times boundary. So find the probability that she did not hit a boundary. How will you find out that probability of did not hit a boundary? Question number 1, answer. Probability of hitting boundary. How will you find probability of hitting boundary? Probability of hitting boundary equal, how will you find out the probability of hitting a boundary? Probability of hitting a boundary, for every 30 deliveries played, she hits 6 balls to boundary. That is 6 times he hits the boundary by total deliveries played is 30. That is 6 by 30 is 1 by 5. So 1 by 5. So this is the probability of hitting boundary. That is probability of not hitting the boundary is probability of not hitting the boundary is 1 minus 1 by 5. That simply means that 1 minus 1 by 5. How will you find out 1 minus 1 by 5? Such that the probability of hitting the boundary is 1 by 5. The total possibility is 1. Then not hitting the boundary is 1 minus 1 by 5. That equal 5 minus 1 by 5. That equal 4 by 5. Otherwise, we can use another method such that the probability of not hitting the boundary, such that she played 30 deliveries. Out of the 30 deliveries, she hit 6 boundaries. That means the remaining 24 deliveries, she did not hit boundaries. So how will you find out using another method? So the remaining 24 deliveries, she did not hit any boundary. That means that the probability of not hitting the boundary is 24 by 30. That is 4 by 5. By these two methods, you can find out the answer. So the next question is 1,500 families with the 2 children were selected randomly and the following data were recorded. So there will be 1,500 families are there with the two children were selected randomly and the following data were recorded. There will be 2 children are selected randomly and the following data were recorded. So the number of girls in the family, 475 families have number of minimum 2 children, number of 2 girls in the family, and 814 families have 1 girl and 211 families have no girl. So probability of question number 1, probability of 2 girls, that is P of 2, probability of 2 girls equal, probability of 2 girls equal 475 plus 814 plus 211 is 1,500. That is probability of 2 girls equal 475 divided by 1,500. Then what about the probability of 1 girl, that is P of 1 equal, probability of 1 girl equal 814 by 1,500. So how to simplify this one? And third one, probability of no girl, that is P of 0. Probability of no girl equal, how many families have no girls? 211. 211 divided by 1,500. So these are the answers to the question. Now moving to one more problem in this section. So one more problem. Rohit Sharma is one of the cricketer. Rohit Sharma scores so many runs in a tournament where he plays 5 matches in the tournament. and the runs he scored is match score. Match 1 74, match 2 83, match 3 44, match 4 100, match 5 39. So these are the scores obtained by Rohit Sharma in 5 matches. So the questions are probability of scoring a century. Probability of scoring a century. As you all know that to score a century, he needs 100 runs. So how many times he scored 100 times? Only one time. Out of the 5 matches, he scored 100 in a one match. So the probability of getting 100 is exactly 100 is probability of getting exactly 100 equal 1 by 5. That equal 0.2. So next one is probability of scoring half century. Probability of scoring half century. So how many times he scores half century in these 5 matches? So first time he scores 74 runs, second time he scores 83 runs, third time he scores 44 runs, fourth time he scores 100 runs, fifth time he scores 39 runs. So how many times he scores half century? There is a confusion in this question such that in the fourth match he scores 100. He scores 100. That is a century. But the question is that probability of scoring half century. After scoring half century, he continues his batting and scoring 100 runs. That means after his half century, he score the century in the same match. So this is also considered as the situation as probability of scoring half century. This is also considered as half century. Okay, so the probability of scoring a half century is, this is half century, 74 runs. He scores more than 50 runs. More than 50 runs is considered as 50 and 50 plus runs are considered as half century. So 50 and 50 plus runs are considered as half century. 74 is 50 plus, 83 is 50 plus, 100 is 50 plus. So there will be 3 times he scores half century, that is 3 by 5 is the probability that equal 0.6. That is probability of greater than 50. That is probability of scoring a half century. So the next one is probability of less than 50. Not scoring a half century. Not scoring a half century. Not scoring a half century. How many matches he played and not scoring a half century? In third match he scores only 44 runs. Fifth match he scores only 39 runs. That means 2 times he didn't score a half century. The condition is 2 by 5. That is 0.4. And the probability of not scoring a century. Probability of not scoring a century. First match he scores 74 runs, not a century. Second 83, not a century. Third 44, not a century. Fourth 100, that is a century. Fifth 39, that is not a century. So probability of less than 100, that means probability of not scoring a century. Not scoring a century, that is P of less than 100, that equal 4 by 5, that equal 0.8. So these are the questions that is given by different exams, different board exams, CBSE exams, such that from the table we want to analyze the things very clearly, such that we have to analyze the condition and compare it with the table. From the table we can find out the answers. Okay. So moving to the next problem. The problem indicates that an organization selected 2,400 families at a random and surveyed them to determine a relationship between income level and number of vehicles in the family. So they done a survey, and in the survey the data sheet is given. So from the data sheet it is clear that there will be a monthly income versus vehicles per family is vehicles per family is given in the table, such that the monthly income of a family is less than 7,000. There is a chance of 10 families that they have no vehicles. There is a chance of 160 family having one vehicle, 25 families having two vehicles, and there will be 0 families having possibility about two vehicles. If the monthly income is between 7,000 to 10,000, there is 0% possibility that they have no vehicle. 305 families own one vehicle, 27 families own two vehicle, and two families own about two vehicle. So this data sheet is given the fact that there is a relationship between monthly income and vehicles per family. We want to find out that. The first question is, how many families, what is the probability? What is the probability of the families earning exactly 10,000 to 13,000 rupees and owing two vehicles? So probability of finding two vehicles, but the condition applied is that that family will uh, earn an income 10,000 to 13,000. So probability of finding the family earning 10,000 to 13,000 rupees and having two vehicles. So how many families having 10,000 to 13,000 monthly income? So this much of families. From this row it is clear that, so how many, from this how many own two vehicles? 29 families own two vehicles. So P of 2, and the condition I write in the bottom such that 10,000 to 13,000. So that equal, from 10,000 to 13,000, 29 families own two vehicles. That is 29 by total number of families is, how many families are there? 2,400. This is the probability. So second one, how many families having one vehicle and the monthly income is greater than 16,000? So greater than 16,000 is here, and the condition is how many families own one vehicle, and the condition is greater than 16,000. They own greater than 16,000 monthly income. Greater than 16,000, how many families owned one vehicle? So one vehicle, 579 families owned. 579 by 2,400. Second question answer. Third question, how many families having monthly income less than 7,000 and there will be no vehicle? So P of 0, we want to find out P of 0, and the condition is less than 7,000. So less than 7,000, how many families having no vehicle? Less than 7,000 here. How many families having 0 vehicles? 10 families. So the condition is 10 by 2,400. So that answer is 1 by 240. Next one, how many families having two vehicles and they earn exactly 13,000 to 16,000? So we want to find out the probability of two vehicles, and the condition applied here is 13,000 to 16,000. That equal 30,000 to 16,000 is here. Two vehicle is 59 families. 59 by 2,400 is the condition. 59 by 2,400 is the condition. Finally, not more than one vehicle. How many families own not more than one vehicle? That we have to find out. At least one vehicle, how many families own? So we have to consider these two tables and take the total sum. 10 plus 1, 11 plus 2, 13, 13 plus 1, 14. 14 plus 160 plus 305 plus 535 plus 535 plus 469 plus 579. Again 114 is missing, 14. 18, 23, 28, 32. 10, 16, 22, 25, 26. 7, 11, 12, 15, 20. 2062. The answer is P of less than or equal to 1. That means at least one vehicle. How many families owned at least one vehicle? At least, not more than one vehicle means at least one vehicle. That is P of X less than or equal to 1. That is equal to 2062 divided by 2004. So this is the answer to the given questions. So this is an important section regarding probability. That is, for playing cards, probability comes into play. Such that in this case there will be a lot of questions will be asked in board exams or terminal exams like that. This is the structure of a playing card. This is the structure of a playing card. There will be 54 cards are there in one set. 2 are jokers that not take into consideration. So there will be 52 cards are there. So from the 52 cards, it will be divided into 26 plus 26. 26 black cards and 26 red cards. So this 52 is divided into 2. That is 26 black cards and 26 red cards. From the 26 black cards, there will be spade and clubs are there. 13 spade cards and 13 clubs cards. So there will be 52 cards are there, valid cards are there. From the 52 valid cards, there will be 26 black cards and 26 red cards. From the 26 black cards, there will be spade 13 and clubs 13. And from the 26 red cards, there will be heart 13 and diamond 13. Okay. So these are the section: 52 valid cards, 26 black card, 26 red card. From the black card, 13 spade, 13 club. From the red card, 13 heart and 13 diamond. From the spade, there will be numbers 2 to 10. There will be 2 to 10 numbers are there in cards. That means card number 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 cards are related to numbers. 9 cards are related to numbers. 9 cards are related to numbers means there will be 9 cards. There will be numerals are there from 2 to 10. So 9 cards are there. 10th card is king. There will be one king card. Then queen card 1, jack card 1, ace card 1. So total 9 plus 4, 13 cards are there. So in the case of black cards, 13 spade cards are there. From the 13 spade cards, there will be one king, one queen, one jack, one ace, and there will be numbers 2 to 10. These are black cards. Again, from the black cards, there will be 13 clubs are there. From the 13 clubs, again simply 2 to 10 numbers are there. One king, one queen, one jack, and one ace are there. Here in the red card also, this is same. This is same. Red card also, in the case of red card, there will be 13 card including one king, one queen, one jack, one ace. Here also one king, one queen, one jack, one ace, and 2 to 10 numbers. That is 9 cards for numerals. So 9 plus 4, 13. Here also king, queen, jack, ace. Here also king, queen, jack, ace. 1, 1, 1, 1, 1, 1, 1, 1. Again, 2 to 10 numbers are there. So these are the structure of the card. 52 valid cards. From the 52, it is divided into 26 plus 26. 26 black card, 26 red card. 26 black cards are divided into spade and clubs. 13 plus 13. Then each of the spade, club, heart, and diamonds, there will be one king, one queen, one jack, and one ace. These three, one king, one queen, and one jack. This combination is called a face card. The combination of the card king, queen, and jack are called a face card. So from this thing is that from the deck of 52 cards, probability of finding two red kings, probability of finding 2 red kings. So how many red kings are there in for probability of finding red kings? The question is only simply the probability of finding red kings from the 52 deck of cards. So from the 52, how many cards are there? 2 red kings. So from the head, 1 king is there, that is red. Diamond, 1 king is there, that is also red. 2 red kings divided by the probability of getting red king is 2 by 52. The probability of getting black king is again here 1, here 1. That is also 2 by 52. So in some exam, it is simply asking that probability of getting a king. The probability of getting a king is, it is not mentioned red or black. It is simply mentioned probability of getting a king. Probability of getting a king is 1, 2, 3, 4. That is 4 by 52. Probability of getting a queen 1, 2, 3, 4. 4 by 52. Probability of getting a jack 4 by 52. Probability of getting an ace 4 by 52. So this is the thing. And what is the probability of getting? What is the probability of getting 2? Probability of getting number 2 from the cards. Number 2 from the cards. From the spade, there is 1, 2. Club 1, 2. Heart 1, 2 is there. Diamond 1, 2 is there. That is 4 by 52. Probability of getting 2 red 2s. 2 red 2. That means probability of getting number of cards such that it is red 2. Red 2. Probability of getting red 2. So here 1, 2 is there, that is red, that is black. So here 1, 2 is there, that is red. Here also 1, 2 is there, that is red. So probability of getting red 2 is 2 by 52. Probability of getting 2 is 1, 2, 3, 4. 4 by 52. Like this, we can find out all the probabilities regarding cards. So the structure of the card is there will be 52 valid cards. From the 52 valid cards, there will be 26 red cards and 26 black cards. From the 26 black cards, there will be spade and clubs are there. Spade card is 13, club card is 13. From the spade card, there will be 2 to 10 numbers, then king, queen, jack and ace. Similarly, from the clubs, from the head, from the diamond, exactly, there will be king, queen, jack and ace and the numbers 2 to 10. So these are the structure of the cards and these are the problems we discussed that will be probably happen in every exams. So these are the complete topic regarding the chapter. From the chapter, it is clear that there will be very limited number of questions and it is an easy chapter regarding mathematics 9th class. So that's all about the chapter. So thanks for joining me in the class. And this is Sudhi signing off from this section and we will meet you in the next section with another class. Thank you.